Okay, today guys, we are going to start a unit on conic sections, and we are going to go through each one specifically over the next several classes, but I wanted to show you what I'm talking about to begin with. What is a conic section? Well, I found this simulation that has two cones. One is with its point up, one with its point down, because you'll need those in just a minute. And the main idea here is if you slice it with a plane, so a plane from geometry, what shape is it going to make? Well, if you go straight across like we have here, you'll notice that little red shape is a circle. So we have a circle, and that's what we're going to be learning about today. But you can get some other shapes out of this. If I move the plane a little bit down, I would still have a circle. But if I can rotate it a little bit, I'm going to have an ellipse. So here is an ellipse, and if I rotate that more, you can see more of an oval shape happening. Okay. Another thing that I can get is a hyperbola, and that comes from rotating to a 90 degree, and we'll slide it off of the center. This is a hyperbola. It almost looks like a parabola on the top and on the bottom, and so we're going to be learning about those. So circles, ellipses, hyperbolas, and then the last one, I'm going to rotate back, would be a parabola. So I have to rotate a little bit, and I'm going to slide it down here. And when it comes off of the cone, you can see just the red being a parabola shape. So those are the four conic sections, and I'm sure that you can search for a conic section visual, and you will find this. It was the first one that popped up for me. Okay, and so now we're going to start with circles. That's what we're actually going to be working with today. And in standard form, the equation of a circle looks like this. You have x minus what we're calling h squared plus y minus k squared equals r squared. You'll be seeing those same letters throughout this unit. Now, the h and the k, what are those? Those are actually from the center. So wherever the center of your circle is, that point is the x and y value we're calling h and k. Most of you have learned at some point that this line I have drawn in is the radius of a circle. That's r. In your standard form, that is r squared. The last thing is sometimes we talk about a point on a circle, and a point that's on the edge of the circle is actually something that works in the equation. And if I'm referring to that, it'll just be a normal x and y value. So let's move on to some problems that we might need to know how to do. Okay, first problem is one where we're trying to get that equation that I was just talking about, given a point and the center of a circle. And so the center, we know, goes straight into the formula. So I'm going to set that up. X minus blank squared plus y minus blank squared equals r squared. And I'm going to plug in the x and y value from that point. So the x goes with the x, so I'm going to put the -2 here. And the y goes with the y, so I'm going to put the -3 here. Now, that will change your signs because two negatives will make a positive, and it will change your signs here. So one of the things that you should realize is always going to happen is the equation is going to have the opposite signs of the center that you're given. So here we're given a -2 in the equation. It ends up being a +2. Here we're given a -3. It ends up being a +3 in the equation. If they had been positive, they will become minus whatever in the equation. And we'll do some examples of that in just a second. Okay, so I have the bones of the equation basically filled out. What I don't have is r. You're not going to see r, you're going to see a number. And so how can I figure out what that radius is? Well, if you think back to your circle, that distance for r is between the center and the point on the circle that I was talking about. And so since that's a distance, I can use the distance formula to figure it out. So I'm going to come over here and I'm going to do my scratch work. My radius is going to be the distance formula between the center and the point 1, 4 on the circle. So if I plug it in, 1 minus negative 2, using those two x values, squared, plus 4 minus negative 3 squared. Again, those are the two y values from over here. And then I start to work it out. So here, this becomes 3, and 3 squared is 9. This becomes 7, and 7 squared is 49. So r ends up to be the square root of 58. Now, notice in the equation that it's r squared, not just r. So let's think for a minute, what would r squared be? Well, if I square a square root, it's going to go away. So r squared is going to be 58. That's what I have in my formula. So now I can come over and I can write my formula. X plus 2 squared plus y plus 3 squared equals 58. That's the answer for this one. Okay, so here we have another example of pretty much the same thing. I'm given a point and a center, and I'm wanting to get the equation of that circle. So if you think you got the first problem, this might be a good place to pause and see if you could get this one. If not, you can listen and I'll explain it. So here, I'm going to do x minus something squared plus y minus something squared equals r squared. And then I'm going to plug in the center, and the 3 is going to plug in with the x, the negative 5 is going to plug in with the y. And again, two negatives make a positive, so it's going to end up with a plus 5 and a minus 3. Then I realize I'm missing my radius, so I'm going to come over to the side, do my scratch work. My radius is going to equal the distance formula between these 2 points. So I'm going to do x minus x squared, and it doesn't matter which x value comes first because you square it, and that always makes it positive. And plus y minus y, so negative 2 minus negative 5 squared. Then I'll simplify. This becomes 2, and 2 squared, or negative 2, and negative 2 squared is 4. Over here, you end up with 3, and 3 squared is 9. And then 4 plus 9 is 13. So your radius is the square root of 13. Since your formula needs r squared, you're going to go ahead and square that, which would be just 13. When you write your answer, you'll have x minus 3 squared plus y plus 5 squared equals 13. Okay, for my next example, we're going to change our type of problem. This kind of problem is not in standard form. It doesn't look like what we've been working with the parentheses. And everything is kind of laid out almost like you would have a polynomial, kind of remind you of that, but it's not because it has x's and y's. So it's not in standard form, and we need to get it there. This is going to make us remember what we did when we did vertex form of parabolas, and that was to complete the square. So here are the steps you're going to take. The first thing you're going to do is separate your x's and y's. If you have any plain numbers, like this 6 right here, that doesn't have a variable with it, you're going to move it to the other side. So I'm going to have to subtract that 6 over. So my first step, I'm going to say x squared minus 6x. I'm going to leave some space. Then I'm going to put y squared minus 2y. And then I'm going to leave some space. And then I'm going to have that 6 that I had on this side subtracted to the other side. And so I have the minus 6 over there. Now, you're going to look at both of these things separately and complete the square as we did with parabolas. And to remind you how to do that, you take the number that's in front of x. You don't worry about it being positive or negative. So here I'm just looking at the 6. I'm going to take half of that number, square it, and add it to both sides. So half of 6 is 3. 3 squared is 9. So I'm going to add 9 here, and I'm going to add 9 here. Because this is an equation, it has to balance out. So if you add weight on this side, you have to add weight on this side. And then I'm going to complete the square with the y's. So again, I look at the number in front of this y. Don't worry about the positive or negative. Half of 2 is 1. 1 squared is 1. So I'm going to add 1 to this side and to this side. Okay, after you do that, this side you should easily just be able to add, and here we'll get 4. These will factor separately. It's x factor factoring. This one factors to x minus 3, x minus 3. This one will factor to y minus 1, y minus 1. They're always going to be the same thing in both parentheses. If you have completed the square correctly, these will end up to be the same, and that is why you can combine them and put squared. So I'm going to do that with the x's and the y's. And now it looks like the standard form that we had been doing. Something that you'll want to notice if you want to jump to this step instead of having to think about the factoring every time, this parentheses will always have the first sign of your trinomial here. So this is a minus, this is a minus. If it's a plus, it's a plus. And this number will always be whatever half of the number you were working with is. So half of 6 is 3. Over here, this was a minus, so this is a minus. Half of 2 is 1. That's how you can jump that middle step. If you feel the need to factor, you can always factor, and it will always work. Okay, now let's identify the center and the radius so that we can sketch it. So my center is a positive 3 and a positive 1. We're just reversing what we did in those first couple examples. So positive 3, positive 1. And then if you remember over here, this is your radius squared. So the square root of that number will be your radius. And this time it's 2. Sometimes you get uglier numbers. They're not always some kind of perfect square, so don't be freaked out by that. And the same thing with your center. You could get some fractions or decimals in here to work with. Everything isn't always a pretty number. Okay, so then when I go to sketch it, it's not going to be perfect. I know we can't draw circles perfectly, but I want to make sure I show where my center is and try to show my radius correctly. So if my center is at 3, 1, I'm going to go over 3 and up 1, put my center, and then if my radius is 2, it should be 2 from that center in any direction. So I usually do a point to the right, a point to the left, 2 up, 2 down, would put this one at -1, and then I try to sketch those 4 points together in a circle as best I can, which is a little bit of a challenge. But I get the idea. I can see the center and I can see the radius. Okay, I have another example of this where we have to complete the square. And again, this might be one where you want to pause and try yourself. So I'm going to separate my x's, leave some space from my y's, and I'm going to move that -4 to the other side by adding it. So add 4 to the other side. When I complete the square with 2, half of 2 is 1, 1 squared is 1, so plus 1 plus 1. Half of 4 is 2, 2 squared is 4, so add 4, add 4. And then this time, again, this side over here, add it up. This will factor. I'm going to show you how to jump to that factored form. X, whatever this sign is, half of this number, squared. And then Y, whatever this sign is, half of this number, squared. So I can now have it in standard form. My center is easily recognizable as 1, 2. And my radius is the square root of 9, which is 3. And then if I sketch that, I have a center at 1, 2, radius of 3. So again, I'm going to try to go 3 in each direction. Put a point there. and try to make a circle as best I can. There's my sketch.